Dragoș Arnautu și cu Adrian Muscateviț, care împreună reprezintă Passive Institut astăzi și Adrian va fi cel care va prezenta, sau cel puțin va începe prezentarea.
Hello. Yeah, good afternoon. I hope you don't mind that I do my presentation in English. I don't speak Romanian, unfortunately, but I hope you can follow up. And okay, I just would like to give you some insights about component certification of the Passive Institute and why this makes sense, especially in the context of the zero energy building perspective and how we can prepare ourselves for the next year. So the title of the presentation is A Chance for the Better. And so we are looking not for, thresholds, we are looking for the opportunity in this case. And I just would like to give you some insights. So what we're actually doing in all the building physics, architecture, engineering is actually a management system. So we do have this kind of PDCA cycle, maybe you have heard of that. So that means plan, do, check, act. And it's like an ever-spinning circle, and we're trying to optimize the things along the way. And optimizing means not only in terms of energy efficiency or lowering the energy consumption, it means also to find the economic sweet spot, to have healthy indoor environments, to achieve the best possible thermal comfort, superior indoor living quality, and to find a proper building concept that suits you very well. So the thing is that we are heavily influenced by external factors such as policy, regulations, but also fundings, and this is continuously changing over time. So we need to adapt very quickly, and what I would propose is to do it right away, regardless of the politics, and strive for a concept that meets all these criteria at the very beginning. So the passive house concept itself is, on the one hand, a functional criterion, which says you can heat or cool a building via the supply air, but it's also related to energy values. So what we're trying to have with this concept, with the 5 main pillars, so have consistent thermal insulation, to have a mechanical balanced ventilation system, thermal bridge-free design, a heat ventilation unit with heat recovery. We are trying to achieve also economic sweet spots, right? And to achieve that, we need a efficiency that allows us to achieve such standards. And it's actually a prerequisite for a couple of things, such as avoiding local and global discomfort. So comfort is what makes people feeling comfortable in their living environment, right? So influencing factors as humidity, air temperature, radiation temperatures, but also we have local discomfort such as drafts, right? So when you're sitting in front of an old window, you feel like the cold air descending. It is actually a requirement for an efficient operation of a heat pump system, right? So, the lower the temperature difference for a heat pump, the better the efficiency. You're flexible in the use of systems, and it allows you to distribute conditioned air also via the supply air. Another really important factor, and this is one of the things we are talking about today, is resilience. So we are in the middle of a climate change. It's nothing that is coming up. We are already in the middle of that. And that means that the summers will be hotter, it will be sometimes drier, it will be sometimes more humid. So we need to make our buildings more resilient so we can achieve thermal comfort also in these ever getting hotter periods. And achieving efficiency helps us to also get better summer comfort or having a better operation during summertime with lower electricity grid peaks and so on. Another aspect that comes into play is the reduction of user influence, right? So the more efficient and robust your building is, the lower is the impact of the user influence, right? It doesn't matter if we turn up the heating to 25 degrees, the consumption is lower compared to an uninsulated building, for example. And another aspect, efficiency gives you a certain freedom. It gives you freedom in the design of your building. So you can, for example, have windows from floor to ceiling without any radiators. You can heat via the supply air, by conventional heating, and so on. So I chose for 5 main topics that we actually need to address when it comes about, when we talk about efficient components. And the first one I already mentioned, this is summer resilience. So that means we need to think of passive measures. Can we use passive shading? Can we use insulation with cool colors? Do we have HVAC components that work for winter and summertime? For example, reversible heat pumps that can have summer operation and cool, and maybe also distribute heat during the winter time. We need to look at the renovation, because this is actually the key to mitigate climate change. It's not the new builds, right? That's one part, but we need to think of the existing building stock. We need to think, how can we renovate them efficiently to not have lock-in effects. We need clever designs, we need installation guidelines, we need a practitioner's tools to make that work. We need to think of the regulations and the directives, like the Zero Energy Building Directive. What will that be for our building concepts? We need to think of circularity of materials, ecology, and where we get our materials from. So therefore, we need to develop tools, available data, we need to be very transparent and have new features implemented in the database guidelines and in the database. Construction costs is a very complicated topic because that is one of the big hindering factors for being efficient. Sometimes efficient design does not need to be more expensive than conventional design. It's about repeating details. It's not for reinventing the wheel all the time. It has been done 10,000 of times. So let's use the details that are promising to make construction cheaper and also more efficient. And on the other hand, we need to strengthen local markets. That is a very important factor also from an economic point of view, that the building should financiate from itself and mainly supported by local manufacturers, local craftsmen, educated people that work on site also for the local economy. So this is what we are addressing in the component certification, which is based on clear targets, on the one hand based upon comfort, hygiene and economics, and we have adaptive goals for each climate zone. So when you would visit the database, you can find approximately 1,300 certified components from approximately 40 categories, and they are optimized for different climate zones, right? So it doesn't make sense to have like a quadruple pane maybe in Spain, and this is why I said we are trying to find the optimum. So for each climate zone, we would recommend the values that are needed to achieve hygiene and comfort. And so when you look at the certificates, you can find that you can see the world maps indicating the recommended climate zone, right? So this is based on economic considerations in different categories. So you can find like the recommendation to achieve passive house or EnerFit standard that should cover all ZEB requirements easily on this list, right? Because the ZEB definition is actually a building that consumes so less energy that can be covered by renewables on site. So that is actually by definition kind of a passive house, right? Because all other buildings will not manage it to cover the consumption on site. So when you would look at the database, you could find the recommended values for the different topics, for example, for the transmission values, for the walls. You can find it here. So the component database is a free-to-use tool, right? So all these components are incorporated in the Passive House Planning Package as well as on the component database, and all these data are there transparently shown. with approximately 30,000 details right now that are offered for free, thermal bridge free or reduced thermal bridges for the construction of things. But it also contains, for example, replacement models if you want to conduct FEM simulations by yourself. So when you have, for example, a complicated 3D structure, such a thermal separation for balconies, you can find guidelines how to reproduce them for yourself in your simulation. It contains manuals and guidelines, some calculators and tools, for example, for windows, window calculators. And what we're trying to meet in the future is that we have a full incorporation into our software kits, such as the PHPP, such as the MEET tool, which allows you to calculate the carbon footprint of a component or of a material, and to develop the user experience more and more. So what you can see here in the background is these are the main categories, but each category contains a couple of subcategories, right? So when you would look at the windows, we have, standard windows, but we have also window systems, fixed glazings, spaces, and so on. Okay, so when you would use the database, you can filter, and this is what I said at the beginning, that this is something really important. So we don't want the components to travel around the world. So you can choose or filter for, your local markets, right? So in this case, you can see the location availability as Romania already depicted, and then the database would show you available components, for example. You can also use the world map and to zoom in and to see if there's like a production site nearby or a seller, a vendor that can bring the products to your country. When you click on detail, you can sometimes see that there's like a manufacturer, and sometimes they have vendors or resellers, so you can find these suitable options here. Another aspect that we're trying to address is improving the certificates for the planning process. So in the past, we often had just, there's like a result, right? It says this is the efficiency value, this is the thermal bridge, this is the value whatsoever. So what we're trying to give now is kind of a guideline, a manual, how to use the certificates and to use them for your own simulations again. So when you look, for example, as such a balcony separation element, they're quite complicated to simulate, right? It's a very complicated structure. You need to run a 3D simulation. But this certificate contains 2D replacement values, so you can run your own 2D simulation with a substitute model like that, so you can use that for your own simulations. And if you don't want to use, you can still find the thermal bridge itself on the certificate, but sometimes it makes sense, especially when you have a changing construction or a combination of different materials, right? For example, in combination with a terrace door. Okay, so one main topic is summer resilience, or the climate change and how that will impact us. And what I just would like to show you, when I'm conducting summer simulations to see if there's a frequency of overheating, I'm just showing you the different data sets for the design period. And you can see that was the design temperature for the year 1985. That was already in the year 2004, the 2010, and the 2030 prediction. And when we look at the 2050 prediction, we even get bigger amplitudes. So on the one hand, we have a general increase in temperature, but what is really challenging for us building planners are the peak temperatures. Because that means, especially the hot nights, that we cannot release that easily. So that makes certain passive measures not as effective anymore. So when it's 29 degrees outside in the night, it doesn't make sense to open your windows because you cannot release the heat properly to a comfort level, right? So when we would say a comfort temperature during summertime might be 26, 25 degrees, and it's 29 degrees outside, we are not improving the comfort anymore. So we need to think of what we can do in these climates in the future. So in the region where I come from, nobody had an AC in the past, right? That was inexistent. I've never seen that until I was an adult, and now it became kind of kind of a mandatory to achieve summer comfort for uninsulated buildings, right? Because you cannot release the heat through the windows anymore. You cannot use the building inertia up to a certain extent anymore to, have some summer strategies. And this is something that we need to address. So it's becoming more and more of a challenge, and this is something we have to tackle, right? So we as planners, we as manufacturers, we as policymakers, whatsoever. And the bad news is, this is just like a general climate data set, but what the real challenge is are the microclimates. So what I'm showing you here is like a typical summer night in the city of Munich, and what you can clearly see that in the inner city center, the temperature is even 5 degrees higher than in the rural area around it, right? And it's not even like woods or something, it's really like villages. And this brings us to the situation where the cities are more and more storing heat. We have high albedo values, like the streets very reflecting. We have black cars reflecting everything. The heat is stored during the day and cannot be released during the night, and we can clearly see that. So that makes it a really challenge for the cities, and that also means when we use active cooling systems, like all the ACs, chillers, whatsoever, they will also release more and more heat and heat up the cities more and more, right? So we need to kind of rethink the inner city context. So, just a quick summary, and this is the prediction of the tropical nights. So by definition, the tropical night is where the temperature is not falling below 25 degrees, depends on what definition you find. But you can see the development in Central Europe, but can see even in the Nordic countries we will get tropical nights in the future, right? So that means in these days passive measures don't work as effective anymore, or it's hard to release heat out of our buildings. So we need actually new concepts for temperate climates. So the hotter climates, they're kind of used to it. We have other problems facing here, like the grid structure, peak electricity, but we need to find solutions in terms of solar coupling, shading concepts, night ventilation, whatsoever. So it might be the case that we need to have a pre-cooling via the subsoil heat exchangers instead of taking the direct air. One thing that becomes more and more important is external shading systems. And this is also like a learning curve, because when you have an AC running, you might not realize how much heat you have actually to cool down and what that means. So I'm just showing you one example, that what the difference between is an unshaded window, so an active roller shutter or whatsoever, and an unshaded situation. And you can see that the daily load is 3 times higher compared to the shaded one, right? And this is actually a passive measure that doesn't cost you any energy and would help us to make use of. So, but we also need a certain development here, because what I often see in consultancy projects is when the offices are shaded, they became kind of dark, right? So what's happening, we use artificial lighting again and counteract that. And you cannot see it here, but on this, so you get maybe sometimes these kind of darkish offices, which require to have artificial lighting although the sun is shining, right? So what we often do is we're trying to find, as always in life, a kind of a sweet spot, and to calculate the point when the artificial lighting electricity consumption is higher than the cooling demand, for example, right? So it's, kind of a challenge for us as engineers. Okay, how can certified components, or let's say great components, help achieving resilience? So it's also important, what you can see on the right-hand side is a steadiness simulation, which shows us the amplitude of the temperatures within an hour for different inertias and effectiveness. And what we can say is that capacity helps a lot, but what's even better is insulation and shading. The good thing is when you have certified components, you get rid of all the local discomfort issues, right? As also during winter time, such as stratification, drafts, radiation asymmetry, and you have solved all hygienic issues, right? So you will not have condensate on the paints forming, you will not have mold growth on surfaces because the water activity is also reduced. It reduces the impact of user behavior, and the passive house is, what we should not forget, is a holistic building concept, right? So components is one part of it, the planning process is another one, but we always try to find a way how to find an economic optimum to achieve resilience, efficiency, and what is really the most important thing, healthy indoor situations, right? So we are spending so much time of our lives indoors, so we should really focus on having healthy situations. And I'm not just talking about humidity or CO2 concentration, it's thermal stress is something which is among the highest risks of mortality right now, right? So, yeah, looking up the numbers of fatalities during the summertime in Europe, these are tremendous numbers. Okay, so load and capacity is another aspect, but that is just the result of that. Another thing we would like to address, and this is what we also do in our certification lines, are the renovation systems, right? So what I said before is applicable for new builds, but also for renovations. But for components, we actually need to tackle some the existing structures. So therefore, we developed like renovation systems that can be certified under the ANAFIT labeling. And you can choose the grade of that, right? So up to a full house renovation, but you can also start with windows and walls, but you can also implement the HVAC. What we are trying to have now is to upgrade the windows to so-called ANAFIT windows, so that it's easier to install for existing buildings, right? So you maybe not necessarily need a installation in front of the wall, you can also direct mount the windows. But we need to develop some proper details of that. And this is especially tackling construction costs, because the actual costs don't lie within the components itself. They usually lie within manpower and site costs, such as scaffolds, such as bureaucracy, such as demolishing, such as waste, right? These are the costs that really driving up industrial costs. And if you manage to install a window within an hour instead of 4, then a passive house window is by far the cheapest option. It pays off by itself due to the energy savings, but it could initially pay off. So that means we need to upgrade kind of the installation situations to get continuous insulation layers. What we also need is collaborative concepts, and this is something where the whole industry is struggling with. So everybody's looking at their specific fields, right? So a window manufacturer does not necessarily look at the installation, they don't necessarily look at the mounting, they don't look at the shading. So we need ready-to-build details, collaborative structures, also when it comes to installation, engines, whatsoever, right? So all these things can be combined in a way better and effective way. The same applies for the window mounting systems, right? They are very flexible, and we got certifications line for that, but we kind of ready to build details, a clear instruction, good guidelines, and we often have a scenario that the windows are installed and 2 weeks later the facade builders come and don't know how to install the components properly, driving rain secure and whatsoever, right? So these are the things we are challenging. We need to address ventilation concepts, especially for retrofits. We know how to do it for new builds, that's not a challenge, but we need to address that for retrofits. How do we get a ventilation unit in an occupied building, right? Without demolishing the ceiling, without having all the ductwork visible? Can we maybe install that in the facade? And that was one of our last research projects my colleague Christine and I did last year. And we're looking at the impact of the ductwork installed in the insulation layer, right? So you can actually do it properly when you have a sufficient amount of insulation. So that could be a new take for renovating ventilation units. Another aspect, and just to mention that there are always some things we cannot decouple, right? So, but they're still necessary, such as column and beams. You know, these are like highly reinforced structures, and you cannot cut them off and put some insulation in between. So we need to kind of reduce the impact. So when you cannot avoid that, sometimes it makes sense to have some flank insulation, but that only gives you a reduction up to a certain extent, right? And if you have like a 1 meter diameter column in the parking garage, you will not put 30 centimeters of insulation around that, right? Because you will use the parking space. So these are a couple of things that we always need to address. Okay, I'm spending too much time on that now. But these components, they sometimes need a different assessment. So as I said before, by its nature, they cannot be thermal bridge free. So therefore, we might need to look at some hygienic points, right? We need to look at dew points and so on. Okay, that was just I went a little bit rapidly through it, but just to address a couple of things. But I just want to sum up my presentation with an advocacy for certified components, because they allow for a contribution to mitigate climate change, and it becomes more of a challenge the longer we are waiting. You can participate in a development for these components, and there are so many fields, so many niches, so many things to address, and I think it's really great what's happening here today, and also talk to the manufacturers what they do to improve our lives, right? So I think it's kind of a fascinating era. Although it's challenging, it's something where we all can contribute. And whenever you have a project like that, we are very happy to contribute, right? So our consultancy is always included, whether it's component certification, building planning, education, whatsoever. So feel very welcome to get in contact with us. And just a little commercial break at the end. So we have the next International Passive House Conference coming up in 26 in Essen. So the call for papers is ending soon. So when you have a contribution to make, we are very happy if you send us a paper to present. If you are in the ventilation industry, the next event that takes place is the Ziventa Lab ventilation workshop that's happening in Lithuania in September. If you're a manufacturer, you're also very welcome to attend our exhibition in Essen. And if you want to know more about how to test components, facilities, we can also meet up in Brussels in October to show you the regulations for the ZTBs and how components are tested in cooperation with our partners, BCCA, Buildwise, and Pasivă. Okay, so this is just a quick overview what the Passive House Institute has to offer on a very rough level. And sorry for rushing through this, but thank you for your attention. Thanks for having me here, and I'm happy if you have any questions.
Thank you, Adrian. I think we have some time for questions, so please.
Thank you. Passive house concept has been inspirational for a long time, and it is still for all following concepts for energy efficiency. But since nothing is perfect in this world, I wonder, have you identified any weak points in this concept? I mean, nothing is perfect. Do you have something that you struggle with in this concept?
Well, So the concept is originally based in heating-dominated climate zones, right? So it has been adapted to several climate zones from the tropics, and we have thousands of passive houses built. I think in the concept itself, that works pretty well. That is physically based. It has been proven and tested thousands of times. What is lacking is lack of components, component availability. So especially in countries that are new adopters, it's kind of a challenge, right? So we often face that, for example, in Australia, right? So they have to import other products. Some are not available. The on-site implementation lacks of education a little bit. So I would not say that the concept itself lacks something, right? That has been proven and tested. But it lacks sometimes in the adoption and availability of craftsmen, of components. But this is something that should develop naturally. And when I just compared, so when I started a PHI 15 years ago approximately, there were just 100 components available, right? And now we have 1,300 in all over the world, for the tropics, for the Arctic. So we've seen passive houses in the Alps in 3,000 meter altitude, in the tropics from Singapore to Australia. So I wouldn't say it's a concept thing.